Friends, in this video we are going to see what is CMOS design style and what is stick diagrams related to few of the gates. Okay, here I will consider directly an example as we considered in NMOS style, and I will explain you the circuit diagram of the using the transistors and also the stick diagram. Okay, before going to the circuit, first we need to know 2 points related to CMOS design style. So whenever it is CMOS, we have both NMOS and PMOS. Okay, here what I am mentioning is there is a differentiation for NMOS and PMOS in whenever we are writing the circuit. Okay, when we are drawing the circuit. Here dot means series, plus means parallel, whereas here dot means parallel, plus means series. Okay, understand this, right? Now whenever you are drawing any circuit for a given function, first complete the NMOS style. First complete the NMOS part, then do this reverse of the NMOS at the pull up circuit, then you will get the entire circuit. Okay, so basically this CMOS style have the circuit like this. You have a supply VDD and one network, another network and ground. This is the demarcation line. This is called demarcation line, which separates the pull up network and pull down network. Okay, now this is the pull up network, this is the pull down network. Pull up network always have PMOS, whereas pull down network always have NMOS. Okay, here I will take the output. Okay, this is how generally a CMOS circuit looks like. Okay, here we give the inputs. Okay, here we give the inputs. These are the 2 points we need to know before going to the designing the CMOS circuit. Okay, now I'll take the example. Okay, consider suppose I'll consider first a OR gate. Okay, NOR gate, I'm sorry. F equal to A plus B whole bar. F equal to A plus B whole bar. Now, whereas in NMOS, what we have done is in the pull-up network we have only depletion mode NMOS transistor, but here it's not that the case. Now, what I told is first draw the NMOS side, then you go for the PMOS. What is the NMOS? It is a pull-down network, whereas what is the PMOS? It is a pull-up network. Okay. Now, as it is plus B, it is NMOS. It is related to NMOS, so I need to draw the NMOS style first. Okay. Now, this is a transistor. This is the transistor. Okay, I give it input A, input B, and as per that these two to be in parallel. These two to be in parallel. This is the ground. NMOS side is finished. Now to get the PMOS side, I need to get the opposite. Now this is A, this is B. Okay, but for what is the opposite of parallel? It is a series, right? So these two be in series. What are the inputs? The same inputs which are given. This is A. The same input B. Okay. Now where we get the output? Here. F equal to A plus B bar. This is VDD. Okay. What are these transistors? This is a PMOS. This is a PMOS. Whereas these two are NMOS. Now how many variables I have? 2 variables. How many transistors I got? 4 transistors. Okay. So that means for n variables, I'll get 2n transistors. Okay. If it is a 3 variable OR gate, then I should have another C. That means I need to have 6 transistors. Okay, for n variables I'll get 2n transistors including PMOS and CMOS. Okay, so this is the transistor diagram of NOR gate. Okay, how the stick diagram will be for NOR gate is, I have VDD same as NMOS. Okay, for everything I have VDD and ground. These two are represented using blue color. Okay, now after that, first what I have, two transistors in series, right? So one transistor, two transistor. Okay, now this is connected to VDD. Okay, and this source is connected to this drain. These both are connected. Okay, here I have demarcation line. There is a demarcation line. After that, I have two transistors in parallel. So I light like this. This is one transistor. This is one transistor. This is one transistor. This is one transistor. Okay. Now these both are these things. These are connected to ground. These are connected to ground. And what are the inputs here? This is one input. This is one input. This is B input. This is A input. Okay. So even these are to be represented using blue color. These are blue color. This is red color. This is red color. This is also red color. Gate polysilicon. Okay. This is in red color. Okay. Now this is the stick diagram of the NOR gate. Okay. This one is yellow color. This one is yellow. Next also, the same. Okay. A and B both are connected as shown in the transistor diagram. Okay. This is called the stick diagram of NOR gate. Similarly, I consider the AND gate. Okay, what will happen for a AND gate? It has AND. So first I need to complete the NMOS side. This is B, this is A. As is a dot, the both should be in series, and the device should be in the PMOS side. So I have one transistor, I have another transistor. A is connected to A. B is connected to B. These both are connected. This is the output F equal to A dot B. This is VDD. This is ground. Okay. This is the NAND gate. Okay. Similarly, the stick diagram. How does this stick diagram looks? This is VDD, this is ground. Okay, exactly opposite to the what we have written for NOR gate. Two transistors. This both end is connected to another transistor. This is connected to another transistor. This is connected to ground. Okay. Now here, this is the output. This is the output. These both are connected. Okay, and these both are connected. This is connected to B, this is connected to A. Okay, so again the same coloring. This is green color, this is red color, this is also red color, this is also red color, this is also red color. Okay, whereas so this part is yellow. This is blue color. This is also blue color. Okay, the stick diagram of NAND gate. Okay, similarly we will see for by CMOS inverter. By CMOS inverter design style. Okay, so not by CMOS design style, it is a for by CMOS inverter. Okay, now how does this by CMOS inverter looks like this? It has a VDD, it has ground. Okay, it has a PMOS, it has an NMOS. Both are given the same input Vin. Okay, so this is given to a transistor again another transistor. Okay, so these transistors both are CMOS transistors. Okay, now here we get the output. Here we get the output, V out. Both are of NMOS type. Okay, NPN, NPN. This is PMOS. This is NMOS.